Great. All right. So I guess we're all here to talk about breaking into ML research. So I'm Maxwell, and yeah, let's begin. So first of all, I'm gonna share these slides. Somehow, I guess I'll talk to the people in charge of the data science club, but everyone should have access to the slides if they want it. So yeah. Let's begin. So I guess first I'll give an overview of the talk. So first I'll give a little bit of my background, a brief introduction about me. Maybe some of you know me a little bit, maybe some don't. Next, I'll talk about kind of breaking into machine learning research. This is like about, getting that first research opportunity or kind of pivoting from one research opportunity to another research opportunity, stuff along those lines. After that, I'll talk about what kind of skills are even useful to gain before you start research. So like say you haven't started research yet, but you want to get into it, like what kind of things should you be prioritizing? What skills are useful to have? And finally, I kind of talk about building good research habits. Right? What should you even be focusing on in your first research project? Right? What are the things that are important for you to learn, and what are things that like you might think are important, but actually aren't as important as you might think? Okay. And feel free to ask questions at any time. This can be pretty informal. Yeah. All right. So first, a little bit more about me and my background. So I'm currently a first-year PhD student in the machine learning department. So I'm co-advised by Junyan Zhu, who's in the Robotics Institute, and Ruslan Salektudikanov, who's in the machine learning department. So I have two different advisors, two different groups. This is a picture of Junyan's group. So Junyan is in like the back right. I should be pretty easy to spot. Um, Also, I was a machine learning master's student at CMU. So I was in the MSML program. This is a picture from a theory work at Uncertainty in AI conference. It was hosted in Pittsburgh this year. So that was kind of annoying, like no travel, but it is what it is. And this is my co-author, Dravian, who's currently a postdoc, I think. And then before that, I was an undergrad at CMU. So I've been here a long time. This is a selfie with me and Marshall Herbert, who's the current dean. He's a fun guy. He's definitely seen me a lot because I've been here since like 2019. But yeah, I guess on the research side, my past work kind of has spanned different areas of machine learning. So I did a project on like bias amplification. So this is kind of a responsible AI project with computer vision. So how does like data set bias affect model training and like a final model being biased? Right? So there's a phenomenon where if your data set is a little bit biased, you can train a model and the model will actually amplify the bias from the original training data set. So we were kind of evaluating that. I've also done some theoretical semi-supervised learning. So this is kind of more on the machine learning theory side, but there was also some like empirical experiments that we ran. But there was like proofs and stuff as like one of the core parts of this work, whereas other works didn't really have as much kind of proof-based stuff. And my current work is kind of in generative image stuff or generating images, editing images or videos. And so I had a master's project on generative image stylization. So this is kind of like applying style to image, training models to output images in certain styles. So my background is kind of in lots of different areas. So maybe I know about different types of things in machine learning a little bit. But yeah, so the first thing kind of towards breaking into ML is what to even look for in an initial project. So I think the first thing I'll say is it's good to have some research interests, but not to be super picky. As we all know, AI is a super hot topic. So everyone's trying to work in the field, do research. But also as a result, because ML is kind of so broad, it spans a lot of different areas. And so there might be parts of machine learning that you don't even know about, right? If you've never been exposed to it. So it's good to keep an open mind. And also, if you're super passionate about one area, right, or one professor or one group, that group might not even be looking for students or looking for undergrads, right? So it's good to kind of keep an open mind about what's even out there. To me, the most important thing, more important than any exact research fit about what you think you like, is finding an advisor or a PhD student that's invested in your success, right? So if you have two different options of labs that you might choose, and they both seem semi-interesting, right? I'd always go with the one where you feel like you're going to be more supported, right? So I think when I was picking research my senior year, right there, I had some options about what I could choose. And I kind of went with the place that I felt like would best support me and like help me learn and grow. Okay. So I think that's something that's super important and undervalued. So I guess next is connecting with possible advisors. So maybe all of you have sent at least one cold email somewhere and gotten a response, or most likely not a response. I definitely have sent out many emails and gotten no responses many, many times. So I think there's many possible ways to do this actually, that go beyond just emailing, although emailing is also important. So the first is talking to professors whose classes you're taking. So my first research experience at CMU was actually with the professor that I took Introduction to Machine Learning with. That was the kind of the theory work. And so the benefits of this approach is if you're doing well in the class, that can help you stand out. Like the professor knows at least a little bit about you to the extent that they know you're doing well in courses, right? You know you can get face-to-face time with them, like during office hours or after class. You don't have to just email the void. And even if you don't end up working with them, they can help possibly refer you to other potential matches, right? Especially if you're doing well in the class, they can be like, oh, wow, this student's so great. They always ask interesting questions. They're doing well. So I think talking to professors whose classes you're taking or that you can generally run into is a good approach. So I also know of people that, met people at seminars that they attended, right? Or any other kind of venue where you get to meet a professor face-to-face. That can be super helpful. Next is asking your academic advisor to connect you with people. I think at CMU, we all meet our academic advisor once a semester-ish. So we should at least be comfortable enough to ask them questions and say, hey, I'm looking for research in X field. Can you help me out? And so actually my current lab, I emailed the professor, didn't respond to me. I'm sure he gets lots of emails. So I asked my advisor to email him for me, and my current advisor responded to my academic advisor. So I think that's also a good way to maybe connect with new professors or just connect with professors in general, because maybe they're more likely to respond to faculty. Okay. You can also ask your friends that do research to connect you. So I know multiple people who kind of joined the same lab as someone that they knew, right? They were both strong students. They could both, the person that's in the lab could then refer the other person to the lab. And then if you really want to do research, an option is like a summer program. So there's this few CMU summer programs. So for instance, this Robotics Institute Summer Scholars is a program. There's this Berkeley Data Science Discovery program. I think the Berkeley page also lists a lot of other programs. So I think those can be helpful. I know we have a master's student in our lab that joined originally from a summer program and then like continued to stay in the lab after that. And finally, I think emailing people is like very valuable, even if like the miss rate is very high. So I kind of think of this as like, say you email a lot of people and very little of them respond, but one or two respond, that's still like very good. And also, like in every lab that I've like interacted with, there's at least a few people that like got there or that got like an interview or talked to the professor just from an email. So I think it's still like a valid way to kind of connect with people that you might not see. And just as a few tips, it's good to not make the email too long. So you can give a short intro, reason why you're interested in the lab, a quick overview of your relevant work. So maybe GitHub projects, internships, coursework, etc. Provide a resume and a transcript if comfortable. And like don't copy paste and send a lot of people the same thing or like ChatGPT something. So I think I've gotten emails where people like ChatGPT summarize like my own paper to me. And I'm like, I know that you did this. I wrote this. I know what it's about. So don't do that. And then like, it's hit or miss. So don't take a non-response too to heart because that's how it goes. And I guess one thing I'll say overall is like working hard in many things is generally valuable. So if you have like an introduction to machine learning course, right? Even if the material might not be something that you work with, like trying very hard in that course will help the faculty be more willing to say, hey, this is a very good student. I'll refer them to my other faculty friends. Right? Or if you do a good group project with someone, they're more likely to say, hey, I'll recommend you to a lab that I'm currently in. So this is kind of like a karma kind of way of looking at things, is that even if you're not working on the exact thing that you want to work on, it can still be a good tool to kind of progress forward, to really try hard and like excel, even if what you're working on isn't exactly your best fit. So I think that's also something that's good to know. I guess from there, we can talk about preparing for research and defining success. So like day to day, what can you do to even get ready to do a good research project or to join a lab and be productive? Um, and so the first thing I'll say is making sure you have a strong fundamental understanding of the basics. This is like your introduction to machine learning, introduction to deep learning, kind of knowing about loss functions, knowing about how to do a training loop, knowing what's going on. I think that's super valuable, especially in a world where it's easier and easier to cut corners, right? Like you can do well in a class without understanding what's going on, right? But that might not help you when you're actually trying to do research and when you're trying to do a future project where you need to do it yourself, right? So it's actually good to put in the time to make sure you understand the fundamentals, right? I saw there's this quote on Twitter that people like to say, which is like, oh, you can just do things. The overall gist is that doing a project from start to finish yourself is super valuable. And like a lot of people never do that. If you're taking courses, you never have to actually write code from scratch, right? And so even training some small model or doing some small project from start to finish is super valuable and you'll get really valuable skills out of it. Or fine tuning some like large model using Google Colab or even a small data set and actually going from start to end and having it work, even if the definition of work is kind of small, can be really valuable and you'll gain skills that a lot of people won't gain just by taking classes. So I think that's also like a really good thing to think about. Another thing that you can try to do is reproduce some cool results from a paper. So a lot of times with machine learning or computer science papers, they'll release the code base along with the paper and kind of like the project page. And so actually getting the code base to just work in and of itself is difficult. And so it's a good exercise if you say, oh, this is a cool result, or they have some cool images. Can I even reproduce those just from the code? Right? This could involve getting all the libraries to work out, downloading the model weights correctly, right? Getting it set up with the GPUs that you have, or getting it set up with Google Colab, right? This in itself is also, like, I think, a very valuable tool towards preparing to do research. And finally, I guess this is the data science club. So you guys know about competitions and stuff. But I think doing some ML competitions, like a Kaggle competition or some other ML competition online, is also super valuable. Even if you don't win or get a cash prize, you can learn from the process. And a lot of times, like the top solutions will release some kind of tech report or some kind of postmortem about what they did. And that can be another way to learn about how to kind of look at end-to-end solutions. Other than that, I guess, if you're ever going to write code or do anything on your own, it's great to push it to GitHub and make sure that your code is to the best of your ability, easy to use for others, it commented, and has a README explaining what's going on. So some like people before they will like look at your profile will check your GitHub before considering you as a candidate. So when I was interning over the summer, one summer, and my manager was trying to hire new people, like he made me check all their GitHubs before we considered hiring them. So people actually do look at this and look at like, hey, is this code clean? Do I understand what's going on? Is it commented? Is it at least, doesn't have to be perfect, but is it at least decent? Right? Does what they say and what kind of is going on make sense? Right? So I think that's another thing to focus on. And it doesn't take too long to clean code and write a README and check that if you start from scratch and use the code base, so you clone it, like it actually works. Right? So I don't think it's a huge burden. I guess the next thing that we can talk about is like, what is success for an initial project? And so it's kind of different for like, say, a senior PhD student than it is for an undergrad or a master's student just starting in research. Right? So I think it's good to not worry as much about like the end result of some collaboration with some mentor figure. Right? A lot of that is kind of out of your control in terms of, does it get accepted? Does it not get accepted? Does the project work out? Does the funding get cut? Right? This is kind of out of your control. Right? And there's some inherent randomness because so many people are doing machine learning these days. Right? So I've had papers that got, rejected a bunch of times, then got accepted. And there's people in my lab who've had papers that, it gets rejected, then they change the initial figure like a little bit to make it look a little clearer. Then in the next conference, it gets like oral best paper or whatever, top 1%. So there's just some inherent randomness in how these things work. So what's better is to try to think about how can I learn the most from this experience? So consistently meeting with your mentor, whether it's a PhD student or whether it's an advisor, like a faculty, consistently meeting is like super valuable. Even if you don't have great results, you shouldn't be afraid of having a weekly meeting with the person that you're working with just to learn more, right? And building good research habits is also a really good goal that's kind of actionable and achievable and that you can work towards, as opposed to this, oh, what might the end result be? And so I guess on the topic of habits, we can talk about what it means to even have good initial research habits. So the first thing that's like very important is to understand key previous results. So like, let's say like now you're in a lab, you're working, you're doing some research. What should you focus on? Right? First things first, you want to understand kind of some of the previous work in the field, and as much as possible, be able to run these baselines or other code bases that you hope to build off. Right? Kind of goes back to just knowing what's going on, being able to be at least a little bit familiar with the details of the code base. That's a great thing to do. Second, you want to write code that's easy to work with, easy to read. But at some point, you may have to have other people look at your code. And so when I was an undergrad and I had a project, there was a time when I couldn't get something working. So the PhD student had to look at my code and like try to fix things. And so the easier I make that looking at my code, the easier I make that process, right, the more that we can work together. Right? So you always want to kind of make your code readable, easy to work with. So this involves stuff like naming all your variables, obviously. Make sure everything is very clear what's going on. And don't make your code so modular that it's unclear like what's going on. So what this means is like, just for a single run, maybe like you have to go through 20 functions inside of functions inside of functions. Like that's like that. And so there's a blog post from Carpathy about this that I'm linking. And once again, I'll send the slides so you'll be able to hopefully look at this link. I think the blog post is super good. It's not that long. Next, you want to like kind of decrease your burden, mental burden, by writing functions that can be used over and over again. Right? So you don't want to have to create a new function every time you train a model with slightly different hyperparameters. You want to kind of create something nice that you can use a bunch of times, right? Or you want to, as much as possible, make looking at results as easy as possible for yourself, or getting numbers for your results as easy as possible, and write code that you can kind of always use again, right? So you want to kind of work smarter so that you can run things without having as much human intervention. Okay. Also, asking questions, right? I guess this is kind of common in whether you're starting an internship, whether you're starting research, whenever you're starting something new, right? You have the maximum leeway when you first start. So use it to its fullest ability by asking as many questions as possible about things that you do not know about, right? You have all the leeway in the world to ask questions, and people are expecting you to ask questions to kind of ramp up to figure out what's going on, right? There are no stupid questions in the beginning, right? If you have a question about like this thing in my environment isn't working, you can just ask like, hey, I really have no idea what's going on here, right? And it's really my true belief that every field has some implementation detail that only people in the field know, that you cannot learn by just like reading the main part of a paper. There's always something that like is a trick to get it to work that you only find by like actually doing the research. So one example is like I do image generation research. And so one of the papers had really, really beautiful images. And when I was training my model, the images didn't look as good. And so it turned out I asked one of the PhD students like, oh, what's going on here? And in the appendix, they said, oh, we have this like validation prompt where we hope the image looks very good for this prompt. So we just train it until like the score for how good that prompt looks is like above a certain threshold. Then we stop, and like that's the one we put in the paper. So I was like, oh, this is silly, because they're training for different amounts for each prompt for the ones they put in the papers. There was like some cherry picking that I did not realize was going on. But every field has some implementation detail. Robotics doesn't really matter. So these are the things you only learn by asking and talking to people who are more senior in the field. And then another comment is it's good to try to work in the same space as your mentor figure, whether this is a PhD student, I guess faculty as well. In general, if you're working in the same space, you can kind of ask questions in more of an online way. So you can kind of query them a lot as opposed to having to email them or wait. And overall, it's just good. In the same way, if you're in an internship and you're sitting next to your manager, it's super helpful to kind of quickly work through kinks. Okay. And also perseverance. So research is hard, and most of the time it does not work. And like that is okay. And it can take a long time to get it working. And there could be many different small implementation details along the way, right? The core idea of a project might only be 20% of what's needed to get it to work, right? So don't let that discourage you. Right? Implementation details are super important. And so being detail oriented is very key to getting things to work. It's even if you have an idea that, even if there's an idea that you feel should intuitively work, there could still be a lot of work necessary to actually get the results to be super good, right? And this can also include pivoting, right? One of the advantages of being an undergrad is you're not tied down to any one lab. So if you work with a lab on some project and you're like, hey, after this project, I really don't like the lab, I don't want to work anymore, it's fine. You can switch labs, right? That's the point of kind of trying different things out. So yeah, and I guess I can go over some key takeaways. One, try to do well with current school and projects, right? The more output you have that's kind of high quality, the more you can get references and the more that people can refer you places, like the better your resume will look. All these things are gonna benefit you towards doing whatever you ultimately want to do. Right? Reaching out to people in many ways. This can look like emailing people. This can look like talking to people in person. This can look like having faculty reach out for you to other people. This can look like applying to different programs. All those are great. Prioritize good mentorship over exact research fit. Right? When you're just starting out research, you don't even know exactly what you'll like to do. Right? So it's good to try to go somewhere where you think you'll like it, and also you'll learn a lot, right? Because in that learning, you can figure out what you like and you can figure out what you actually want to do. And finally, maximize your learning from your mentors by making sure to ask questions, right? Trying to be in the same space if possible, and like knowing that there's nothing stupid that you could ask, and it's okay to kind of figure out more just by asking questions. Right? All right, that is it. Thanks very much. And I guess I will take, are there any questions? Mhm.
Um, if you're planning to pursue a PhD, do you
Mhm.
recommend doing like a master's degree first, like you did, or is that extra time spent?
So I guess the question was like, if you're planning to do a PhD, is it worth it to do a master's? I think it depends on like how much research output you have during your undergrad, and then also talking to your advisor about what they think. So PhD is like very recommendation based, more than it is based on everything else. So if you ask your advisor, hey, like, I'm thinking about only applying to PhDs, and they're like, well, you should consider a master's program, then maybe you should consider a master's program. But it's definitely true that people do PhDs right out of undergrad. So I think what I did is when I was a senior, I applied to like some master's programs and then a few PhD programs, like only the ones that I would take above doing a master's program and trying to get. Right. So I think that could also be a good approach, is saying, hey, I'll apply to master's programs. There's a small set of PhD programs that I'd rather do right away than doing a master's program. But if not, then I'll do this master's program. Also, I think um, there's benefit to doing a master's program and coming in like slightly more prepared to do a PhD because you can kind of hit the ground running more. But I definitely think both can work and like have worked. So for instance, like in the machine learning department, there's both people that did a master's program and people that came right out of undergrad. Yeah. Yeah.
So coming from as a freshman,
Mhm.
I'm really curious, like how necessary is doing like a master's in machine learning compared to like just directly going into the industry?
Okay.
I really want to break into like machine learning.
Okay. So I guess the question was if you're a freshman, how important is doing a master's over not doing a master's if you want to go into industry? And so I think the answer is like 4 years ago, like you had to do a master's. And now like you don't really have to do a master's if you want to like get a good industry job. And kind of the reason for this is because like in the past, like the undergrad curriculum did not support having a lot of knowledge about machine learning like coming out of undergrad. But now you can do that. And there's things that you can do to learn kind of end-to-end projects to get a good industry job, like a machine learning engineer type of job, even out of undergrad. So I think if you're trying to aim towards machine learning engineer type of job, you don't need a master's. And then you can really prioritize like doing some end-to-end projects, doing some cool stuff during undergrad. But at the same time, a master's I think is always beneficial. So I think like a quote from one of my friends, like who's like older, like in the industry, is like, I never knew someone that like regretted doing a master's over like going to industry right away. Right. So it can be very helpful. And I think people also use it as like a tool to like wait out a market downturn. Or to say they don't get the job they want, to do a master's and then kind of try to enter at a higher level. So I think there's always going to be some merit to doing a master's. But if your job is to like really target a machine learning engineer type of job, especially at CMU, like you can get that type of job out of undergrad if you have like a very strong resume. And you do a lot of cool projects and you have trained models and you know about hyperparameter searching, et cetera, et cetera. Yeah. Mhm. Yeah. So like going to like if they have a class going to their office hours, or like if you're in the class, like if you're not in the class. Yeah. So I guess the question is, if you're in a professor's class, is it good to go to their office hours to ask for a research opportunity as opposed to emailing them? Yeah, I would definitely say going to their office hours and like meeting face to face is super helpful. So I think I would recommend that, and you can introduce yourself and say, "Hey, I'm in your class, and I was wondering if you had any research opportunities. I'm very interested in your field. I really liked X and Y work. I'd love to connect with some PhD students or anyone if you have some opportunity for me. That would be great." Right. And then maybe they'll say yes, maybe they say no. If they say yes, you're happy. If they say, I don't know, I'll think about it, and maybe you're less happy, you can wait it out. And then I think it's also fine to say, hey, if you don't have any opportunities, do you know any other faculty that are in a similar field that are also looking for opportunities? Because you have that face-to-face time, and like I see you're doing good in the class, so maybe they have some faith that you're like a good student. They can say, hey, blah blah blah, student is doing very well in my class. So do you have any opportunities for them? So I think that's also something that can be helpful. Yeah. Any other questions? Yeah, questions?
So you're doing a PhD where you did your undergrad and stuff.
Yeah.
And I think like some people don't encourage this. Like maybe like some professors at CMU or some admissions committee.
Yeah.
Also, I mean, CMU is a large place.
Mm-hmm.
Staff will stay here. What do you think?
So I guess the question is, do you recommend doing a PhD like in the same place as your undergrad and master's? I think like to me, the thing that's more important than if you're at the same school is like, do you have a good advisor? So like I worked with my advisor during undergrad and masters. And so I knew that like, he was very good. I could meet with him weekly. Like he wouldn't like ghost me for like 2 months. Like if there's a call, if there's a paper deadline coming up, he like, be in the trenches with me at 2 a.m., like helping me write my submission. Like the lab is very collaborative. It's not cutthroat at all. So these things are all super great. And not all PhD students can say the same. Right. So I think that was like the biggest part of my decision. I think also it's good to talk to students like at different universities in the lab of people that you're applying for. So say I got into X school with Y professor, then I talk to Y professor's PhD students and say, hey, like, do you like it? Like, do you cry every day or every other day? Like, so I think it's good to kind of gauge the vibes, but I think both can be good. Yeah, I think from an admissions committee standpoint, they don't care as much. I think definitely for faculty, that's a big thing. Like you're not really not supposed to do like you're not supposed to be faculty at the same place you did your PhD. But even that rule I've seen broken. So I don't know. But yeah, I think like advisor match is like much more important than like same school versus different school. Any other questions? Yeah. Yeah. Okay, so I guess the question is, what criteria do you look for in terms of support from your advisor? So there's two different answers. There's one if you're kind of like an undergrad versus if you're like a PhD student. So as an undergrad or someone who's joining the lab that's not a PhD student, to me, it's less important whether you get to meet directly with the faculty a lot versus you're directing like weekly with the PhD student. What's more important is that whoever like mentor figure is for you, like you can meet with them on a consistent basis, and they're always like trying to help you like improve. So whether that's a PhD student or like faculty doesn't matter too much. But what's really important is that there's someone who's kind of looking out for you and trying to help you improve. And like if you don't do anything, they're like, hey, it's fine, right? Like say you couldn't get something to work, like it happens, right? So I think that's the most important thing from just joining the lab perspective. From an advisor perspective, yeah, I think like being present is good, at least for me. I think there are some people who kind of have a very strong vision themselves and can get 90% of the way there themselves. So maybe they would prefer like a hands-off advisor. But I think for me, I really wanted someone who like I could say is like very hands-on, who can help with like high level ideas and low level implementation details, at least for the first few years. And then also like the lab is very collaborative. So like people always help you with your papers before the deadline. You help people with other papers, etc. So yeah. Any other questions? All right, cool. Thanks very much. Yeah. Great.